Now that we've gone through systems of linear equations, we want to talk about what happens if you have something other than a line. So a nonlinear equation would be something like a circle, a parabola, anything along those lines. A system of nonlinear equations means at least one of the equations is nonlinear. And our ultimate goal is to find those points of intersection or points that satisfy both equations. So you could potentially get imaginary solutions to these. So let's look at some examples just kind of graphically before we solve them. Here's two equations. One of them is definitely nonlinear, and there's going to be a single point of intersection. So we have one solution here. The strange thing that can happen with nonlinear is you could have multiple points of intersection. So if I shift that parabola down a little bit, I've now got 2 points where they intersect. So I have two solutions. If they're both nonlinear, then I could potentially even have 3 solutions. So I've got 1, 2, 3. So I've got 3 different places where this intersects and 3 different points that will definitely satisfy both equations. To actually solve them, we're still going to use that same process of elimination or substitution. It just might be harder, or you might have a more complex equation that you have to solve. So what I'm going to recommend, we'll go through and just solve this system first. If possible, try to use elimination. Otherwise, then go through and do substitution. But if you're solving for one variable when you've got square terms, it's not so easy and straightforward. If both of the equations are nonlinear, it can pose a lot of issues. So elimination is going to be a good first step. And in this case, it's going to be hard to eliminate these y values because you have a y and you have a y squared. But I have x's here. So let's go ahead and eliminate x for this specific problem. So I've got my system, and I'm going to move this x over to the other side, the 1 to the other side, to get y squared minus x is negative 1. Now if I want to go through elimination, I need to multiply one of these equations by negative 1. So let's just do this top equation. So that's going to give us minus 2y plus x equals 0. And then we've got y squared minus x equals negative 1. And I want to go ahead and add these together. My x's cancel, and I'm going to get y squared minus 2y equals negative 1. So this led me to a quadratic that I now need to solve for my y values. So we can solve this quadratic equation. Add that 1 over to the other side. It factors really nicely. And then I get a single y value that solves this resulting equation. Now to find x, you can use either equation to go back and do that. But I'm going to go ahead and just pick this first one. 2y minus x needs to equal 0. Plug in that y has to be 1, and you end up with x equaling 2. So I found a single point where these two intersect. But let's go ahead, because this wasn't bad numbers, let's check this does actually work. So we've got this original system. If you go ahead and plug in 2, 1, you'll get 2 times 1 minus 2. That indeed does equal 0, so it's a point on the first equation. If you plug in 1, you're going to get 1 squared plus 1. That needs to equal x, which is 2, and indeed it does. So this works as well. So now let's actually check with graphing, because you might have missed a solution. Graphing is a good way to kind of see if we did. So if we look at this, rearrange it and solve for y, it's just a line. And then x equals y squared plus 1 is going to be a parabola. So 1/2 y goes through 0, 0. It's got a slope of 1 over 2. So here is the equation of our line. So that's 1/2 x. So if we graph the parabola now, it's a sideways parabola. It moves to the right 1, and then it's got our basic parabola shape. So that's going to be x equals y squared plus 1. And indeed, we have a single intersection point, which is 2, 1. Okay? So as a little remark, you can get extraneous solutions. So check your answers. With a caveat, it might be very difficult to check some of your answers. So if possible, do that. Or at least graph to see if there are real solutions to the equation. It won't tell you if there are non-real solutions, but at least it'll give you some idea of what's going on. So let's try another one. Let's do these two equations. And I'm going to go ahead and graph them at the beginning, just so I know how many answers I should potentially have. They're both circles. This first one has center 1, 0, radius 1. This circle has center 1, negative 1, with radius 1 as well. So I've got my first circle, its center is right here, and the radius is 1. I've got a second circle whose center is right here, doesn't actually go through that point, and it also has a radius of 1. So these definitely intersect in 2 places. So I know there should be 2 solutions. They might not be pretty, but there should be 2 solutions. So now I've got to figure out, how can I eliminate one of these variables? If I expand this stuff out, I'm going to have x squareds, I'm going to have x's. I've got y squareds and I've got y's. But if you notice, this is exactly the same as this in the second equation. I've got an x minus squared in both of them. So what I can do is eliminate that exact term by taking the first equation and multiplying it by negative 1. So I'm basically going to negate everything here, add them together to make these 2 disappear. So we've got our 2 equations, and I want to go ahead and multiply this first one by negative 1. And that's going to lead to this equation, so everything becomes a minus. I don't touch this at all, and I want to go ahead and add them together. But now when you add them, those are exactly the same thing, but opposite signs. And now I've got a y squared plus 1, or y plus 1 squared minus y squared. And then negative 1 plus 1 will also cancel out, and we'll be left with 0. So now I need to solve this resulting equation, and the only way I can do that is by expanding this out. So you FOIL it, now some nice stuff happens because our y squareds disappear. So I need to solve 2y plus 1 equals 0, which is just 2y equals negative 1. And that tells me my y is going to equal negative 1/2. Now I need to find the corresponding x solutions. And so you can use either one of these 2 equations to do that. I'm going to go ahead and pick the one that's a little bit simpler, y. We'll use that first equation. So y has to equal negative 1/2, so we'll replace that here. That tells me x squared, or x minus 1 squared, plus 1/4 has to equal 1. Subtracting a 1/4 gives me x minus 1 squared equals 3/4. Now when you go ahead and take that square root, be careful because you need a plus or minus with it. And that does simplify. You can take the square root of the numerator and denominator separately. So x minus 1 needs to equal plus or minus root 3/2. So I really get 2 different solutions for x. So this one y value corresponds to 2 x values. So I've got 2 solutions. My first one with the positive, and then my second one with the negative x in between. But my y coordinate in both cases is still going to be negative 1/2. Okay? And then like I said, here it's going to be really messy to check. I don't want to plug this x value back in. I don't want to square. I don't want to deal with it. But I did know I should get 2 solutions from my graph. Likewise, if you get complex solutions, don't necessarily have to go back and check everything. The graph's not going to help you there, but do your best with these problems. Okay? So let's try one more, because in the next section we're going to go through inequalities, so we'll still get some practice with these types of systems. And we're going to solve this system. One of these is a circle. One of them is going to be an ellipse because you've got different constants in front. So what I want to do again is try to eliminate a variable. You could eliminate x squareds or y squareds, up to you. I'm going to go ahead and work with the y squareds. So I need to get these to be the same coefficient but opposite in sign. So let's just multiply it by -3. My top equation will be -3x squared minus 3y squared equals -15. Haven't touched this one at all. And then I want to go ahead and add them together. My y squareds will cancel, and I'll be left with a single x squared equals -4. So when I take a square root, I still get that plus or minus, but I'm taking the square root of a negative number. So I get plus or minus 2y. So I still get solutions, they're just imaginary, and they won't correspond to intersection points. They still solve both equations, just I won't be able to tell graphically that these two intersect. Now we need to find the y values that correspond to each of these x values. So I'm going to go ahead and just use that first equation again because it was a little bit simpler. So I'm going to start with my x value being 2i. That'll give us 2i squared plus y squared equals 5, which is 4i squared plus y squared equals 5. Remember, I squared is -1, so this gives us -4 plus y squared equals 5. Y squared equals 9. So when I take a square root, I get two solutions that correspond to this single x value. Now I got to do exactly the same thing, but with x being -2i. So I get this equation, but that minus sign ultimately doesn't make a difference. I get the same thing as a result. So I could keep solving this, but I know my answers are going to be plus or minus 3 for y. So ultimately, I get 4 solutions. I've got 2i with +3 and -3 from these two possibilities. And then I've got -2i paired with the +3 and with the -3. Okay? So you could go through and check. It is going to take a while to go through. But if you did graph these, you would have not known that there would be solutions to them. Because the two curves wouldn't actually intersect. But at least then you would know if you got real solutions, you had a problem because they shouldn't have had an intersection point. So mostly with these, it's going to just take a lot of practice and a lot of getting used to. But elimination is going to be your best friend.